Development, enhancement of latent fingerprints. At crime scenes and on items of evidence, three types of fingerprints may be encountered: patent, plastic, and latent. A patent, or visible print, doesn't need to be processed to be recognized as a fingerprint. Fingers touch a surface after the friction-ridged skin has been in contact with colored materials such as grease, dark oil, dirt, paint, or even blood. Plastic prints, or alternatively known as impression or indentation prints, are recognizable fingerprint indentions in a soft receiving surface such as putty, soap, and gum. They have a distinct three-dimensional character and often require no further processing. A latent print requires additional processing to be rendered visible and suitable for comparison. This processing of latent prints is called development, enhancement, or visualization. To start understanding latent print development, we need to talk about the fingerprint residue. Friction-ridged skin, as found on surfaces of fingers, hands, and bottom of feet, has pores leading to sweat glands. These small sweat glands, called eccrins, make a watery type of sweat which is deposited onto the skin surface, and the composition of the eccrine sweat forms the basis for latent fingerprint residue. Another type of sweat gland, called apocrine, is on other parts of the body and secrete a more oily sweat. This can become part of the latent print residue if the person touches skin with apocrine sweat glands. There are a number of common constituents of most latent print residues, but their proportions can vary and many other compounds and materials can be present. Listed are some of the common inorganic constituents. Some of the major inorganic constituents are sodium, potassium, and calcium. And a minor inorganic constituent is magnesium. These are some of the common organic constituents. Major amino acids present in sweat and latent print residues are alanine, aspartic acid, glycine, ornithine, and serine. Some of the major lipids that are present in sweat and latent print residues are fatty acids and triglycerides. One of the most difficult aspects of fingerprint examination is the location of latent prints. The reflected ultraviolet imaging system RUVIS can locate prints on most non-absorbent surfaces. RUVIS aims UV light at the surface suspected of containing prints. When the UV light strikes the fingerprint, the light is reflected back to the viewer, differentiating the print from its background surface. Once a print is located, the print can be developed in the most appropriate fashion. Hard and non-absorbent surfaces, such as glass and painted wood, are preferably developed by the application of powder or treatment with superglue, which we will discuss later. Classically, physical methods do not involve any chemicals or reactions. They work by applying fine particles to the fingerprint residue, where it adheres preferentially to the fatty components of the residue, creating contrast between the ridge and the surface. The most well-known method is powder dusting with inorganic powders that come in a variety of colors using a camel's hair or fiberglass fingerprint brush. The resulting visible print is then lifted using transparent lifting tape and mounted on a backing with a color maximally contrasting to that of the powder. A variant of the simple brush and powder combination is the magnetic brush. The original commercial version is the Magna brush, which is not a real brush but a retractable magnet. The magnetic brush uses special magnetic powder that adheres to the fatty components of the print residue. The Magna brush does not have any bristles to come in contact with the surface, so there is less chance that the print will be destroyed or damaged. Latent prints on soft and porous surfaces such as papers, cardboard, and cloth generally require treatment with one or more chemicals. Elemental iodine is a substance that sublimates or sublimes, meaning that it transforms from solid to gas without passing through a liquid phase. Though iodine fuming is placed under the chemical methods category of latent print development, it doesn't react with any of the components in the residue. It is thought to interact with lipid components in the residue and get trapped in the residue. The vapor can be applied directly toward the fingerprint residue with an iodine fuming gun, or the object can be placed in an enclosed cabinet filled with iodine crystals. Resulting iodine prints are not permanent and begin to fade once fuming process is stopped. Therefore, photographs of the prints must be taken immediately upon development in order to retain a permanent copy. Also, iodine-developed prints can be fixed with a 1% starch solution or a 7,8-benzoflavone or a naphthoflavone solution. Another chemical used for visualizing latent prints is ninhydrin. Ninhydrin reacts with amino acids present in trace amounts in perspiration to form an adduct called rumen's purple, a purple-blue color. Ninhydrin is most commonly sprayed onto the porous surface from an aerosol can.
The anhydride reaction is slow unless accelerated by heat in the presence of humidity. Anhydride analogs have been used to develop new chemical methods. DFO is an anhydride analog that visualizes latent prints on porous materials when exposed to an alternate light source, and shown to develop 2.5 times more latent prints on paper than anhydride. Anhydride developed prints can be treated with metal salts to cover Rumen's purple and another compound that would yield strong fluorescence under illumination. Cyanoacrylate fuming, or commonly known as superglue fuming, is a chemical method used to develop latent prints on hard and non-absorbent surfaces as well as non-porous surfaces such as metals, leather, and plastic bags. Superglue is approximately 98 to 99% cyanoacrylate ester, a chemical that visualizes a latent fingerprint. Cyanoacrylate ester fumes interact with latent fingerprint residue by polymerizing in situ, yielding a stable white friction ridge impression. Superglue fuming can be accomplished in a closed cabinet or chamber or through the use of a small handheld wand that heats a small cartridge containing cyanoacrylate. Though superglue fuming can be accomplished without any acceleration, it is very slow. Therefore, a strong alkali or heat is used to accelerate fuming. The process also requires a certain level of relative humidity, and a moisture source is always placed in fuming chambers. The last chemical method we will discuss is physical developer. Physical developer is a silver nitrate-based liquid reagent. It is a photographic type process that deposits silver onto a latent fingerprint residue from a ferrous or ferric redox couple in silver salt mixture in solution. Unlike anhydride, which reacts with water-soluble components in the latent print residue, physical developer reacts with lipid and other water-insoluble components. It has become a common follow-up method to anhydride on porous surfaces such as paper, and is very effective on porous articles that may have been wet at one time. As a general rule, objects believed to have latent fingerprints on their surfaces should be collected intact and submitted to the laboratory's latent prints section for examination. If collection of the object or surface is impossible or impractical, investigators must consider applying latent development techniques at the scene. Fingerprints developed in situ at a scene must be photographed prior to any lifting or other collection effort. Prints developed in the laboratory must also be photographed to document the results. Latent prints that have been visualized must be permanently preserved for future comparison and possible use in court as evidence.